Good afternoon and welcome to IPMI's Mobility and Summit session, How and Where to Strategically Locate Public Electric Vehicle Charging Infrastructure in NYC. Before I get started, I want to remind everyone that today's session is being recorded. All lines are muted, and we ask that all participants stay on mute throughout the presentation. If you've dialed in, please make sure you press *6 on your phone line. We will have a specific question and answer period at the end of the presentation. If you have questions for our presenter, please type them in the chat and we will get to as many questions as time allows. And now it's my pleasure to turn it over to Chris.
Thank you, Justin. Appreciate the opportunity to present here today. I'm going to be talking about electric vehicles and parking, and more specifically, I'll discuss a little bit of this case study I've been involved in with some of my colleagues on how and where to strategically locate charging infrastructure for electric vehicles in New York City. So a little bit about myself. I'm a postdoctoral researcher at NREL. I've been there for about a year and a half. My background is in civil, environmental, and sustainable engineering. I did some research related to parking and transportation systems modeling in my Ph.D. and more on the urban heat side of things. But I have some backgrounds in environmental systems analysis, as well as transportation energy systems modeling. So a little more about NREL, if you've not ever heard about us or as familiar, we're a national lab. We're funded usually mostly by the Department of Energy to do a broad array of scientific research focusing on renewable energy and sustainable mobility. And so in my group, we focus a lot on ways we can enhance sustainability of our transportation system. So I'm really excited today to talk about electric vehicles and some of the implications we might see in the future with parking. And just coming from a little bit maybe of a different perspective, sort of on the, we're more like a little bit of like an academic institution in some ways, the way we conduct our research. We usually propose for grants and we sort of help bridge the gap between nascent technologies and research to commercialized technologies in industry, and also helping inform cities and states and their planning for sustainability. So generalized outline here is I'll first go over some broad trends we're seeing in vehicle electrification, and then give you a little bit more background on the technology itself. I think there's a couple of interesting things to just be aware of and keep in mind for context, especially as we start to discuss the more specific applications of where to locate charging, especially in a region that's very unique like New York City. And then I'll wrap up with some of the implications for the future of infrastructure and parking management. So to start, if you were watching the Super Bowl last month or a few weeks back, and or you've been just following the news closely, I'm sure a lot of us all are. You've probably seen how there's a lot of new news and a lot of activity around new technologies for electric vehicles. A lot of the big automakers have recently announced that they're going to be they're promising to go zero emissions or all electric here in the near future, as soon as 10 years away in some cases. And so, GM is promising by 2035, they'll have only zero emission vehicles, which is pretty significant. Now, a zero emission vehicle isn't quite the same as an electric vehicle, but generally speaking, we usually sort of use similar terms. But just to give you a little bit more background on what kinds of electric vehicles there are, just so we're on the same page. I'll probably refer mostly to plug-in electric vehicles in this presentation, as those are the ones we're obviously going to need to put infrastructure in public for to support the switch from gasoline to electricity. However, there also are hybrid electric vehicles that don't plug in, and they kind of reuse some regenerative braking and other technologies to generate and use some electricity. And then there's, of course, partial zero emissions vehicles, but those are usually more on the hybrid side without the plug-in feature. So in this presentation, I'll mostly be focusing on the vehicles that can actually plug into the wall outlet or plug into a charging infrastructure unit. And so, GM's proposing a lot of this, a lot of these new vehicles. We've seen, many other car makers also follow the same. And with this new administration, we're also seeing pledges to electrify vehicles, especially even potentially electrifying the entire federal light duty fleet. Which is pretty significant. And, compared to where we're at today, in the not so distant future, trying to switch completely to electric vehicles is a huge hurdle. And there'll be a lot of things that we'll need to overcome And some of that might be relevant for when considering how we manage urban space, manage parking spaces, and plan for future travel trends. So yeah, there's a lot of hurdles to actually achieving widespread vehicle electrification. And so just to kind of go over some of the broad strokes, we'll have to be able to treat the entire electrical system as an integrated single system. So this means that not only will we be treating buildings and all the appliances and things we use inside, we'll also need to be treating the cars as part of that system now, and so that we can manage the demand for energy in sort of one central location and make sure that we're providing energy where we need it to all the different things that we use in our daily lives. We're going to need to invest quite a lot of money and time and effort into actually expanding our electrical grid to support all this extra energy generation that we'll need to support vehicle electrification. So it may not be quite as obvious today, but if we want to electrify a significant portion of our vehicle fleet, a lot of the projections are that we'll need to double the entire capacity for generation of our current electricity grid. And so we've seen some recent problems happening in the Texas grid where those were more related to some planning and not having all the weatherization needed, but it just shows you that sometimes if we're not planning correctly, the grid can be very vulnerable, and if we don't have enough generating supply, we won't be able to meet the demand of all the people that need to keep their houses warmer in the future, charge their vehicles. So currently we take a lot of that fuel from the ground, and it's we're sucking it out of the earth and we're putting it into the vehicles, but we need to be able to generate all of that energy or a lot of that energy in the near future if we want to actually electrify all these vehicles. And there's some other considerations when it comes to hurdles. You may have heard the term before, range anxiety. So this is this phenomenon that people who are looking at potentially owning an electric vehicle may be a little bit anxious about how far you may be actually able to drive on the battery. And a lot of this is sort of the technological unfamiliarity, people not being as familiar with the different types. And in some of our talks with our partners in the industry for vehicle manufacturing, they put it pretty plainly. A lot of people don't actually understand the difference between a plug-in hybrid electric vehicle and a fully electric vehicle. And so I'll get a little bit into that in a minute, but all these kinds of hurdles can make it a little bit difficult. And so while there's a lot of recent news about how great electric vehicles are, and yes, that we do want to improve urban air quality, we do want to help fight climate change and electrify our vehicles, but there is significant hurdles that we need to overcome. So just to be cognizant of all these. But on the right side, this figure here is kind of giving you an overview of how quickly households might adopt new technologies over time. So this is a historical look at some things like automobiles, refrigerators, color TVs, and so on. And these are these kind of traditional S-curves where in the nascent stages, in the early years of the technology, you don't see a whole lot going on, but pretty quickly things can ramp up. And before you know it, in a few years, almost everybody could be having a color TV in their home. So, we might see the same thing with electric vehicles, but we have these hurdles to overcome on the way. So just a couple facts that maybe you don't realize, maybe you do, but if not, hopefully a little extra context. Plug-in electric vehicles, so again, the hybrid electric vehicles and the battery electric vehicles, and for those of you, again, who may not quite understand the difference, the hybrid electrics still can plug into the grid. They have a battery, but they also have a fuel tank for gasoline. So you can use either or, and it's that nice flexibility that if, you might run out of a little bit of range on the electric part of your car, you can switch over to the gasoline and comfortably, complete your trips. So some people prefer those just for that sort of extra, safety net. But then the battery electric vehicles, or the fully electric vehicles, as we sometimes call them, those are fully electric and no gasoline, no other fuel. And these are Teslas are all fully electric vehicles for reference. But all of these electric vehicles that plug into the grid, they currently only make up a fraction of a percent of all vehicles on the road. So very, very small percentage still. And currently Tesla accounts for about 80% of all of the fully electric vehicles. So they don't offer any of the hybrids, they just offer the fully electric, but they dominate that market. And not only do they dominate the vehicle market, they are also relatively dominating the infrastructure market. Tesla traditionally provides, you may have heard, these superchargers, so these really fast chargers that can charge your battery really quickly. And they account for nearly half of all of the available publicly usable fast charging. So there are a couple different charger types, and I'll go into that too in a minute. But this is pretty significant. Tesla's cornered the market on these technologies, and this has made it a little bit difficult in some ways for providing enough charging infrastructure for the other types, because these chargers for Teslas are actually proprietary. You can't use your Chevy Volt or your Nissan Leaf to plug in at a Tesla supercharger. And also, not surprisingly, California is the leader in electric vehicles. They usually account for about half of all the sales in the current stock. So a little bit about the charging, some technical details here, but I think it's pretty interesting just and pretty relevant to understand the basic differences between the three different main types of chargers. Because when we're thinking about putting in chargers in new locations, especially at public spots and maybe at your parking spots or in your cities, there's different kinds of chargers that are going to be used in different situations. And so there's three types. There's basically the level 1, which are the most basic technology. They're the oldest. They're slower in terms of how fast they can charge your vehicle. They're also pretty cheap. They usually only are going to provide about 2 to 5 miles of range per hour. So that's a very slow rate, which means they're really only used for people charging their own vehicles at home. Level 2 chargers, these are sort of the mid-tier. They're often the ones you'll probably most likely see around outside. They will often charge at a rate of about 10 to 20 miles per hour of charging. So you can usually get in maybe a half day of trips or even a day of trips, depending on how many short trips you're doing in your car with just a few hours of charging. These are a little bit more expensive to install. And so the picture you can see, they're a little bit more of a proper unit that you have to put in and then connect to the power supply. But then there's the really important DC fast charging, or DCFC. And DC stands for direct current. So the other two are this alternating current, similar to like your appliances that you plug in at home. But the DC fast chargers, because it's direct current, it sort of bypasses the need to alternate the current. They're very fast. You can get a lot more range in your vehicle and a pretty quick charge, but they're very expensive. But because they're very fast, they're very advantageous, specifically for the public case. So when it comes to high vehicle adoption, especially in dense areas where there's a lot of parking demand, a lot of travel demand, a lot of activity demand, these are where we were going to target putting in these fast chargers, because the fast chargers will allow sort of quick turnover on spaces to sort of quickly charge up the battery or top off your battery and then go on to your next activity or trip. And so just to kind of also recap on some of the important things to consider in terms of where these chargers you might expect to see them. Obviously, it's really important to think about public versus private access to charging. We usually expect a lot of charging to be done at home, but not everybody can always charge at home. And also just, by needing to travel long distances for vacations or visiting family and friends and all these other things that we do, we also want to have an established network of chargers near the highway infrastructure and out in other areas where we want to visit, so that we make sure we have plenty of it available, but we don't want to oversupply it either. And so we typically are going to see the slower chargers at home, the level 1 and sometimes level 2 if you can afford to pay for an upgrade. There's also the commercial charging, which we usually see. Usually these are public locations where we see level 2, which again, can offer a moderate amount of charge, but typically the level 2 charging at commercial locations, you might not be able to charge your full battery, even half the battery, if you're only going to be around for 30 minutes or so. And then of course the DC fast charging is pretty advantageous in some locations to help that high turnover rate in those quick chargers. We most commonly see the level 2 charging in public at workplaces. It just kind of makes the most sense, since we don't really need that really fast charging at people's workplaces, as often pre-pandemic, when we would, a lot of us would drive to work. You could plug in your vehicle if you had an electric vehicle at a workplace charger on a level 2 charger, and you could probably charge most of the battery within only a few hours while you're at work. So just understanding that, workplace charging, we're most often going to be talking about level 2, while we're trying to look at fast charging for those public scenarios where we're going to have higher turnovers and need a lot of people to be able to use them in a shorter amount of time. And then another takeaway, despite this pandemic slowing down vehicle sales and obviously a little bit of a depression in travel overall for cars, we still have a lot of growth in the infrastructure to support electric vehicles. So there's still the growth in electric vehicles now, and we're expecting that to continue. And as sales pick back up, this will really help. Okay, so now I'll get a little bit into the case study, as promised, where we're looking at strategically locating this charging infrastructure in New York City. And so we're actually looking at the whole state of New York, but just in terms of what's most interesting and some of the takeaways we're seeing and some of the unique challenges we're seeing, I think it's most relevant and interesting to look at the New York City region, but it is an objective of us to try to help support the New York State's goal of meeting their plug-in electric vehicle stock of 850,000 by 2025. And so this is very significant, a very lofty goal. And if you look, when I mentioned in the previous slides about the all these automakers and TNCs, Ubers, and Lyfts, pledging to come and provide more options for electric vehicles, or pledging to entirely offer electric vehicle service, that's pretty lofty goals in the near future. And so is this goal. 2025, we're only about 4 years away now. And as you can see in the bottom corner here, the current state of New York only has roughly about 50,000 plug-in electric vehicles. So another 800,000 to go. And at this point, I think it's safe to say that's probably going to be pretty difficult to achieve without some really aggressive incentives. But nonetheless, we began writing this proposal and got this proposal awarded, before the pandemic happened. And so just due to limitations with, data and coming in and just sort of what we promised, we're not considering COVID in this analysis, just FYI. Of course, as we get more information about how people will be traveling differently and how, sales maybe rebound for vehicles, we'll have a lot more information to, model a COVID scenario or the COVID impacts into the future. But for now, we're kind of just pushing forward, assuming that things are going to be happening as if there were no pandemic, just as an exercise to determine where we can optimally locate infrastructure. And we'll look at a number of different scenarios since this is a really aggressive goal. There's probably a number of different ways which you could achieve it. So, often one of the common ways is to offer vehicle rebates. If you buy an electric vehicle, you can file on your taxes and get some money back off of the purchase price of the vehicle. But there's other ways in which we could potentially incentivize their adoption too. This figure here on the right is just showing you sort of the spatial distribution across the state where most of the electric vehicles are located as of 2018. And so, you'll see a little bit more of the density is around the metro area. And then there's also this county, I think it's Tompkins County in, I think it's Ithaca, New York, and Cornell University, where there's a little higher concentration elsewhere in the state. And so, as I mentioned, there's a lot of hurdles and challenges to electrifying vehicles broadly across this whole country, and overcoming, perceptions, as well as just overcoming some of the technical challenges that we have to in terms of providing enough infrastructure. But there's also a lot of unique challenges for New York City's case that I think we're finding really interesting and have made us think really, we have a lot of tools that we can use to understand this and engage with our project partner, NYSERDA, to understand, what are the needs of New York and what are they looking for? But there's a lot of challenges. So one of the biggest ones is just, quite frankly, the uniqueness of travel in Manhattan, especially, but, New York City more broadly, much higher transit penetration, very high density. And of course, it's rather parking constrained. And I know that there's a lot of debate on, is parking oversupplied in New York City or not? And whatever the case may be, there is still a finite amount of space in the urban land, and especially considering there is quite a lack of parking lots. And so it's a different sort of look when you have to install infrastructure in a lot versus a garage. You might have to account for actually getting into the building a little bit differently. There's also a lot of differing assumptions about how the adoption may occur. And so again, I mentioned, we can offer potentially rebates, you can think about other incentives, but there are factors that are just going to be implicit in the way people are currently owning vehicles and currently traveling that will fundamentally limit how they will adopt electric vehicles. So to give you one example, if you drive to work for an hour every day, round trip or even one way, you may not really want to have an electric vehicle, especially if there isn't a lot of infrastructure around, just because you will be less confident that you'll be able to charge your vehicle at your destination on your way home if the battery gets depleted. So just understanding people's own travel needs and how they differ across the region is really important. Understanding the distribution of vehicles, like where are all the pickups owned versus where are the compact vehicles owned. We don't have any electric vehicles that are pickups that are offered currently. I know there's some promises from Tesla and other car makers now, but those aren't probably going to be coming out anytime soon. And so, we expect the needs of people who own an SUV or that own a pickup to make different decisions based on the type of vehicle they own now. And so, that also is going to influence where we might see vehicles being adopted in the region and in the state. Also, again, a really unique part of New York City and Manhattan especially is just that there is a lot of high density and shared living, not a lot of single family residences. So this fundamentally limits the ability for people to charge at home. And so this is actually really important because it's most convenient to be able to charge your vehicles at home if you can just plug it into your outlet and you can charge it overnight after you've done all your trips. And you probably wouldn't even need to charge it every night, but just to have that flexibility is really convenient and makes it really easy and to adopt a vehicle and feel more confident in being able to do your daily activities. But without the available public infrastructure, especially on those trips on the margin when you want to say, hey, now I want to go and I want to visit family in upstate New York or wherever it is. If there's not enough infrastructure along the way or at your destination, then you might not make that trip with an electric vehicle. And at the end of the day, we're trying to promote the adoption of the vehicles as well as their use, in a more widespread manner so that we can minimize greenhouse gas emissions and improve air quality by reduction of tailpipe emissions. So with the ability of many residents lacking the ability to charge at home, we have to provide sufficient infrastructure in the public, at parking spaces and public locations to make sure that as vehicles are progressively increasingly adopted, that we can provide enough supply, but hopefully we won't provide too much supply. And then also it's important to consider the differences between the fleet vehicles and sort of fleet ownership of vehicles such as taxis, Ubers, Lyfts, and municipal fleets like police vehicles, utility vehicles, versus the personal ownership of an electric vehicle. And how their use will differ and the needs of those competing uses will cause different needs to charge the vehicle at different times of the day and potentially in different locations of the city. As I mentioned earlier, if we do see pushes to electrify fleet vehicles for government fleets like the federal government fleet, that could potentially be very different than if all those vehicles were adopted in the personal side of the market, where people drive to and from their house and to the grocery store and to work, whereas the fleet vehicles, they're used a lot more per year, a lot higher vehicle miles traveled, and they may be much more concentrated in the urban areas for delivering packages, moving people and goods and things. And so all this comes down to the fast chargers of these high-powered level 3 chargers being really helpful in the state of New York, or in the case of New York City, to help meet that demand, because a lot of people won't be able to charge at home. There may be a lot of constraints when it comes to looking at all the parking availability in the region, especially where there is matching grid infrastructure and the differing ways that they may evolve. So we're really focused on looking at the fast charging in public and where we should put fast chargers to meet a lot of that demand. So part of the reason we were contracted to do this work with the state of the New York State Research and Development Authority was because we have a number of capabilities and expertise of the research staff to look at electric vehicle adoptions using our different modeling tools, and to understand at a more finite level where the vehicles are being driven by modeling individual agents picking up passengers and moving those passengers around the city. So This is just a kind of an overview of the general approach and some of the tools that we use. So the kind of the first step that I've talked about is we look at different potential pathways to meeting that 850,000 vehicles. And maybe we assume different levels of subsidies or rebates for them, or none at all, and see where they're adopted. And then we'll also need to look at where the current parking supply is in the region. And then not only where the current parking supply is, but also where the grid supply is. And so, with these fast chargers, because they pull direct current, they need to hook up to these high-powered transformers, which aren't always available everywhere, and are going to serve sort of higher demand energy areas. And so if we want to supply these high-powered units in places, we sort of need to look at where the parking exists, where the infrastructure for the electricity grid can support these fast chargers, and then also consider things like amenities and access to for the general public to make sure we're putting them in a well-used spot. And then finally, once we have an understanding of where the infrastructure exists for both parking and the grid, as well as where we are projecting the vehicles to be purchased in terms of across the region, we can then simulate future scenarios of, seeing where the vehicles are actually driving across the city, and determine where the best locations are depending on the time of day demand and the geospatial demand. So where they're adopted matters. I talk about all these different scenarios that we are evaluating, and we're evaluating these using the Transportation and Energy Mobility Pathways model that we developed at NREL. And the challenge is just broadly that, if we tweak assumptions about how people prefer to own EVs, or how they make decisions on buying a new vehicle, this can heavily impact how the vehicle ownership will evolve. And so I mentioned earlier, people who currently own pickups, we wouldn't really expect them to purchase an electric vehicle in the next 5 or so years, because there probably won't be any available options to buy a pickup. And we're not really expecting the needs of people to, in terms of the type of vehicle they own, in terms of the class of vehicle they own, to change. And so, you expect that people who own pickups, especially, you can see in this bottom left figure here, in the state of New York, a lot of them are in upstate New York, which may relate to just more agricultural or rural regions, and the needs which differ for those, those population and those households. Whereas a lot more of the compact vehicles are going to be in the metro region. And again, that's why we will expect a lot more adoption of electric vehicles in the metro area of New York City. But despite that, there's still quite a lot to go. And so the model we're using is actually it simulates mode choice and vehicle adoption at the household level, in each individual county, based on the different constraints of travel in those regions. Basically, we can look at each county and determine what's the distribution of the types of households. Do they live in urban regions? Do they live in rural regions? How much access to transit do they have, like in terms of bus and rail? And what kind of vehicles do they currently own? How many people are in their household, and how many of those people drive vehicles? All these things are different factors that we put into our model. And we can then tweak the different levers, such as how much rebates we offer, and how much infrastructure we iteratively provide over time, to see how our expected, how the model performs, and how we expect the adoption to occur over time. So this is still ongoing work. So I unfortunately don't have any of the results of where we're expecting the vehicles to actually exist in terms of the final numbers. But like I said, we're expecting a high concentration of the vehicles to be adopted, at least in the near term, in the metro area. So again, looking at, we want to look at where the fast charging ability is most likely to be effective. And so after we've looked at adoption, we're also looking at the supply side. Where does the infrastructure exist for parking? Where does the infrastructure exist for these transformers that can support these high-powered charging devices? And then what other things are around that we may consider to be valuable, so that we can prioritize the locations of competing spaces and competing infrastructure. So this picture on the right is giving you sort of a snapshot of the progress of what we've done so far. And, we basically have just taken sort of the geospatial distribution of parking, and in this case, it's shown as these little dots, not as geometric shapes. And then the green is the specific parcels. And for each of these green highlighted spots, they have a transformer with the adequate capacity to support at least one high-powered charging unit at a location where there also is at least a few parking spots that we could consider converting to electric vehicle only, or just installing the space there. And so we have to determine how much capacity there are at the transformer level. And so a couple of my teammates who are a little bit more well-versed on the electrical engineering side have done a lot of that effort to understand, how much headspace exists on these devices. And, surprise, surprise, in New York City, there's a lot of these powerful transformers just because there's a lot of skyscrapers, a lot of big buildings, a lot of people doing a lot of things which need a lot of energy. And so there's a lot of these high-powered devices. So we actually have quite a lot of options in the New York City region in terms of where there is parking infrastructure intersecting with the currently available grid infrastructure to support the charging. And so the bottom kind of shows you the general flow. We look at the land use, then we determine if it contains parking. And we also want to look at some of the amenities surrounding in the area. So it's really important to actually consider the access. Obviously, we're only really looking at public charging because we want to prioritize the ability of people who aren't probably going to have access to charging their vehicles at home, or may have limited access to charging their vehicles at home, to have options in the public in the dense area of New York City. And so, we have to define public access, which sometimes it seems pretty obvious, but all the time it may not be. Apartments, offices, and warehouses, those generally aren't going to be considered public, although we could talk about potentially locations where it might be effective to put in high-powered charging units at apartments. It's not really going to be it'll require a lot more effort for the municipalities to enforce that, by changing regulations or land use policies, zoning policies, to begin to require, as some cities have already done this, to begin to require a certain amount of spaces to be dedicated to EVs only. But when it comes to the public access, there's a little bit more leverage there. But really importantly, we also want to consider surrounding amenities. And so we want to locate parking spaces, EV charging spaces at parking locations in areas where there is some nearby amenities that people might, gain a little bit of extra use out of visiting. Because when we're talking about charging, even though these are really fast chargers, they can compete with the speed at which it takes to pump gas into your tank. But believe it or not, that's a really quick way to fill up our fuel. You can fill your gas tank in a matter of minutes. And we're probably pretty far away from doing that at a widespread level with these fast chargers to fill your whole, at least to fill your whole battery up with sufficient energy. But so, you'll probably be waiting around for 10, 20, 30 minutes. Maybe if it's one of the slower chargers, you may even have to wait a little longer if you need more energy just to get back home. And so making sure that we're considering the surroundings for different types of amenities is really important, so that if you're going to be parking for a half an hour to charge your vehicle or top it off, you've got a grocery store nearby, you can go sit down for a bite to eat or a drink or whatever. And so this is just kind of the flow chart summarizing this supply side approach. Just again, to kind of quickly go over it, we take in real estate data and parcel data and merge them together to determine, where is the parking exist, where there are amenities based on the land use, to determine if they're good locations, and if there is at least a couple spaces such that we don't, dedicate a small lot or a small amount of spaces to, mostly EV charging. So if it meets those requirements, the next step is to check for amenities in the surrounding area. And luckily, in the time of, or in the area of Manhattan and New York City, there's often a lot of available amenities just because it's a dense region. So this isn't usually a limiting factor in most cases. There's usually a lot of opportunities for nearby amenities. And then if there's enough amenities by, the final step is to kind of look for these transformers to make sure that they can support these high-powered fast charging stations. And so it is also important to note that for this project, we're really only looking at kind of the short-term projections. And so, I'll give you a little bit of peek into this in a minute, but we're not really considering, building more grid infrastructure. That's not really sort of what we're contracted to do in this project. So we're not considering the evolution of the transformers. And in other words, if we see that there's a lot of demand projected in a couple of years in a certain location of the city, but there's no transformer there, well, that's something that we can communicate to our partners. But the lift to install new charging infrastructure, to install new transformers is quite a big deal, and it's much more complicated than just putting in a charging infrastructure device that can hook up to a transformer that already exists. So it becomes expensive, and there's some red tape there. And so that's another kind of future long-term goal, to actually understand where we might need more transformers as the demand evolves. So to give you a snapshot of where the current charging supply is, so there's a couple figures here on these next two slides. So on the left side here, I've got all the level 2 public chargers in and around the metro area of NYC. So you can see there's quite a decent distribution, maybe a couple hundred, almost maybe a few thousand. So there's a lot of available options, but again, these are the slightly slower. A lot of these are likely at workplace locations, which may not be completely public. Maybe you can sneak in and park, but there could be restrictions at some of these. And then the right side is showing these, the third level, the fastest availability charging infrastructure. And there's a lot less of those around. And you can see there's a decent amount of them distributed across the region, such that you could probably drive through, and if you needed to top off your battery at some point, maybe there won't be a lot of demand just because there's not a lot of vehicles on the road. But however, as I had mentioned earlier, Tesla has cornered the market and dominates right now, and it actually infects the infrastructure pretty strongly. So the left figure here again is showing is all the chargers that are not Tesla only or Tesla proprietary chargers. And so again, you see a lot of them out there, but when we look at only the fast chargers that are non-Tesla, which again are ones that anybody could use to charge their electric vehicle, there's like a few dozen maybe, and only a couple even in Manhattan currently. And so, this points to the fact that we actually need quite a lot more, especially as we're not anticipating Tesla to continue dominating the market so aggressively, because, well, they may continue, and it depends on how they evolve their offerings of vehicles. But generally speaking, historically, Tesla's offered, more on the luxury side. Their vehicles can get a little more expensive, so they're less accessible, to the lower and mid income. Tesla has really cornered the market, and there's not a lot of available public infrastructure here in New York City for all vehicles to use. So there's going to be a lot of competition for the few spaces that currently exist. So to give a peek into some of the simulations results that we've been doing, so this is some preliminary results from the Hive modeling, and I'm just showing some relative numbers here, but just to give you an idea about the spatial distribution of demand. And so this is a scenario where we're only modeling a higher penetration of fleet vehicles. So again, this is going to be taxis and TNCs mostly. And the demand, if you can't quite understand, if you're not as familiar with the region, that's basically Manhattan right there, the green spaces that you see highlighted. So there's a lot of actually excess supply in Manhattan. And so, I mentioned that there's a lot of constraints and challenges, but when we consider the intersections of amenities, available transformers, and then parking infrastructure, we actually have quite a lot of options to put in different fast chargers. And again, this is because there's a lot of these high power transformers that are supplying a lot of energy and just happen to have enough extra headroom that we could squeeze in a couple chargers or a couple plugs in various locations. And again, that's also where a lot of the demand is for fleet vehicles. So it's nice to see that there's lots of options there. However, when you kind of look out at the rest of the boroughs and the surrounding area, you'll see a lot of the color is kind of this sort of green tinged yellow or orange tinged yellow. So this is kind of right in the middle of even supply and demand. And this is, again, with the current, just looking at what's currently available and then where we could potentially, fill it out to support. And so given everything we have available, in some cases, it might not even be enough, which points to maybe we do need to build more transformers. Hopefully, we don't need to put more parking. I think the parking is usually not a huge limiting constraint. We were really only expecting it to be potentially most limiting in Manhattan. But with the availability of these high-powered transformers, we see that there may be a lot of options. So again, the goal here is just to balance the supply and demand and ensure that we can strategically locate chargers in different locations so that we're not providing too much and oversupplying these expensive pieces of infrastructure, but also making sure that we provide enough, especially with a little bit of a lead, just so that people continue to adopt the vehicles over the next few years. And so some of the next steps when it comes to locating the infrastructure is, once we understand the distribution of demand for charging the vehicles in space and time, we can look at where we actually want to put the different plugs to support that charging demand. But of course, there's trade-offs that arise even at this, for single plugs. And so it's also important for us to consider how a single plug or a single piece of the infrastructure is utilized at various locations in the city, so that we can understand, as we put 4 plugs or we put 10 plugs in a big parking area or a big demand area, is the 10th plug being utilized? Is the 9th plug being utilized? And so we can easily identify where we need at least 1 or 2 plugs, but getting that sweet spot is going to sort of require looking at how often these marginal plugs are being utilized and compare, just the quality of service that we're delivering throughout the day. And so these are just some hypothetical plots to give you some different insights into sort of how we're kind of thinking about this. So obviously, as the utilization is really high at a plug, and it basically means that for these fast chargers, the turnover is fairly high, and there's hopefully not a lot of dead time for using these. We're getting a lot of bang for our buck, but as you provide more and more plugs, you may see the utilization for that, that 6th, 7th, 8th plug in a big lot being less and less utilized under lower penetration scenarios. And so just understanding if there's a lot of value to having enough wiggle room and a couple extra plugs to make sure that during the peak hours of the day, we're providing everybody with enough charge that they can get back home, or they can finish completing all the trips that they're getting requested on their apps and everything, or they're serving through the taxi service, is really important to consider. So now I'm going to kind of just go over a couple of the key points for, I think, that the implications for parking infrastructure and management, and just a couple things here that I wanted to mention. So first, there's obviously just been an increase in the competition for urban space as cities are densifying and as we've built out a lot of the infrastructure, especially in a city like New York City. There's not a lot of extra space to do infill development in NYC. So there's a lot of competition for space, but this isn't unique to New York City, and a lot of cities are following suit as they fill out the infrastructure and continue to sprawl a little bit. So when we're thinking about the competition for space, and specifically the competition for parking, we're not really expecting the demand for parking in general to change at all based on strictly EV adoption. So, the idea that if we take one vehicle that's gas and replace it with an electric vehicle, that alone isn't something that we expect to change the demand for parking in aggregate. However, as we begin to adopt more and more vehicles and incentivize their adoption to meet these, city and state goals for, reductions in GHG and promoting better air quality and sustainability, EVs will, inevitably take up more and more of the market share of the vehicles on the road. And with this, especially as we, have seen already, mandates for a minimum number of EV charging spaces and new developments in some places. As you start to require more and more spaces to be EV only, you're then constraining parking such that the gas-powered traditional cars couldn't park there. Or maybe they could, and then you have to enforce it, or you have to come up ways to balance that sort of competing need. So that's something I think is really important to consider that I haven't seen discussed a whole lot yet. But it is important to also note that in a scenario where we have 50% of all vehicles electrified, we won't need 50% of parking spaces to have charging. We'll need far, far less. I don't remember the exact numbers off the top of my head, and it will probably change as we evolve, but it's something like, at absolute most 2 to 1, but probably a lot less, probably like 1 charger or 1 plug for every 10 or so vehicles. And again, it depends on how many people are going to be able to charge at their own home. Because if you're mostly able to charge at home, we'll need a little less public infrastructure, which means we won't have to constrain as much of the parking availability to EVs only. But if we're putting infrastructure in public spaces and we want that to be utilized only by electric vehicles, we have to begin to think about how we're going to be able to manage that space and enforce that only EVs are parking there. And so I think this really just ultimately underscores the importance of parking management, because we want to be able to use the space as effectively as possible. And one more thing I'll mention, I don't know that I got an opportunity to mention this before, but generally speaking, we are talking about off-street parking here. Sorry if I didn't mention that earlier, but there is the possibility that on-street parking, curbside parking could be paired with charging infrastructure, but we don't really expect the fast charging to be very viable there. Actually, NYSERDA, the research agency authority for state of New York, has done a study. It's called, I think, Curb Enthusiasm, a nice little play on words there. And they evaluated using level 2 charging at curbside locations in the city of New York City. And they found it to be potentially viable. So again, there's cost constraints and there's slower chargers, so it might not make a lot of sense in certain areas where we expect a high turnover of vehicles. But in areas where we might see a lot more residential parking on the curb, then we could maybe start thinking about level 2. But generally, we're really focused on a lot of off-street parking for supporting the EV charging. And so I think that this sort of also kind of goes hand in hand with our shift to doing a lot of things on the cloud and through app-based services. And just kind of leveraging big data and cloud computing and the ubiquity of smartphones to be able to manage the need for electric vehicles to charge, but also the generalized need of all vehicles to park or use the curb. And I think we've seen a lot of cool technologies and a lot of interesting things come out here in this conference, as well as a lot of the recent research that's been done. And so there's a lot of opportunities, I think, and I'm really interested to see where this space goes. But I just thought it's a really interesting opportunity to begin to think about how we might pair the competing needs of electric vehicles with the need of traditional vehicles to park in the generally the same areas. And so this picture here on the right is giving a peek at an NREL technology where we've actually started to look at an app-based service where you can scan a QR code of your charger, then authorize it to charge your vehicle, and you can pay on the app there and manage how long you can park there on that app. So I think it's very interesting, and that pretty much wraps up my presentation. Left a little bit of time for questions, and so looks like there's a number of questions in the chat. So yeah, I'll begin. Let me take a peek. So Robert asks, can you share the algorithm you utilized to produce this analysis? How did you automate this process to scale to a place like Manhattan? And did you run into any issues securing readily available electric grid transformer information? We've struggled with the electric grid capacity information and automating this location selection process. Yeah, I mean, so as someone else mentioned, Con Ed is a little bit more progressive. They've been working with us fairly well. But even then, it's still a little bit of a push and pull. Luckily we've got a decent relationship due to just various amounts of different projects that have a lot of overlaps in terms of looking at the electrical grid, looking at other types of renewable energy in addition to electric vehicles. And to be honest, I'm not the one who's been heavily involved with interacting with Hoehne. That's one of our other researchers, Brendan Borlaug. But yeah, it can actually be a pretty big constraint. And believe it or not, sometimes the things that we have the biggest issues with is just understanding where all the parking is, where all the grid infrastructure is. That's a huge hurdle on itself that maybe I should have listed more explicitly. Is if you don't have the data, it becomes even harder to model and understand, especially into the future, about where we might expect things to change if we don't even know where it is now. Ron asks, what is the projected impact on the electrical grid as PV adoption is more mainstream? It's pretty significant. So if I didn't highlight it enough earlier, if we're trying to electrify a significant portion of the vehicle fleet, again, that's energy that was previously taken out of the earth, that's been there for a long time, that we're now needing to generate through our own infrastructure. And so, especially as if we're shifting to trying to focus mostly on renewable energies and cleaner energy technologies, it also puts a lot of strain on being able to make sure we can provide enough base loads. So, when it comes to things like solar and wind, they have limitations in terms of being able to always provide enough energy at any point in the day, as they can be more intermittent. If it's cloudy out or not windy in a region, then you might not quite have as much generating capacity. So we need a lot of generating capacity, and some of that has to come from either more natural gas or more nuclear, depending on how we decide to sort of evolve our grid. But at the end of the day, yeah, we will need a lot more. And estimates are that if we're going to do a widespread adoption of electric vehicles in the near future, we'll probably need to about double our generating capacity, which is a pretty big deal. Mike asks, does this work informing consideration of EV charging in public right-of-way curbside, or primarily focused on off-street parcel-based options? Do you see most EV charging demand being satisfied off-street, given DC fast charging investment and infrastructure requirements? Yeah, so I didn't talk about the off-street versus on-street until the very end there, so apologies about that. But yeah, it's mostly focused on the off-street. The public right-of-way is also, I think, a really great opportunity, but just the physical limitations of connecting to the grid can be problematic, especially with the fast charging. So the level 2 can make sense, but again, it can be problematic if you're not also managing. So I would say, if we want to think about, or we feel the need that in order to meet the demand in the future, we're going to have to start putting charging infrastructure on the curb, then we also need to absolutely be managing the curb really well, because we're going to need to make sure that as soon as somebody is done charging, they can vacate that spot and free it up for someone else. So it just kind of adds an extra dynamic to the complexity of curb management, especially with all the competing needs in terms of delivery vehicles and fleet vehicles versus the personal use. And then you also said, do you see most of the EV charging demand being satisfied off street? Yeah, so we will expect it to mostly be satisfied off street, just given just the limitations of where we can actually provide it. Moira asks, are there apps to alert people that their vehicle is charged? What about a way to sign up for a charging shift? So 8 to 10, et cetera, 2 to 12:30 to 2:30, et cetera, especially for work environments, a way to turn off the space for the next time to get in line. Would there be a charger be locked until the next reservation has arrived? Yeah, this is a really great question. I'm not familiar of the specific type of technologies that already exist, but I anticipate that this is exactly how things will start to shift, if not already. I'm sure some startups have already looked into this, and I think that the work we've done, I don't know that you actually reserve the spaces. I think that because we're so involved in all the renewable energy research, the pilot in our own lab, I think we just had so many spaces that there was no need to actually have a reservation going on. But yeah, exactly. I think that helps really manage demand if people can get on board and participate using their apps or their phone or whatnot to reserve space. That will make it a lot easier, not just for managing the parking demand, but really for managing the grid demand. It's really important, even on an hourly level, to understand the next hour of demand. And if you're expecting a huge spike in energy usage in the next hour or 2 hours because of a significant drop in temperature or a lot of vehicles going to the same place at one time or something, then yeah, we would want to be able to anticipate that and make sure we've supplied or are going to be supplying enough generated energy at that same time. So yeah, I would really hope that we begin to sort of pursue those types of apps, but I'm not aware of any of the specific ones at the moment. Someone asks, not sure if asking the right question, but would it be an average cost for charging a vehicle with a fast charger, weight per kilowatt after installation of all equipment? Yeah, exactly. So I didn't touch on the cost to charge and sort of the instantaneous each time. But yeah, typically speaking, a lot of chargers these days are actually free. Not so much the fast chargers. A lot of the level 2 are often free. But of course, the fast chargers, given all the expensive installation and the expense of the equipment, obviously, and recouping those costs for whoever decides to install them or whatnot. And interestingly enough, today, in some cases, if you're only charging via fast chargers, you could even spend more on electricity per mile to travel than on gasoline equivalent to travel. And again, that's a kind of unique case. It sort of depends if you're traveling a lot and you need to use a more expensive fast charger. But there are cases now where that could happen. So, also as the technologies become more prevalent, we're hoping that the costs to the users decrease so that anybody can afford to top off their battery when they need. Anthony states, when putting in EV charging, don't forget about federal and state regulations on accessible spaces. Must have accessible charging stations if supplying it. Yeah, that's a really great point that I really haven't touched on here, and I don't know that we've considered it a lot. So that's something that we should definitely look into a little bit. But absolutely, I mean, when it comes to accessibility, we need to also consider that there's a little unique constraints there, and making sure that vehicles that need to use accessible spaces can also find an appropriate amount of places to charge. And I imagine that will be a pretty complex issue given a much smaller subset for people looking for that demand. So great point there, Anthony. Noah says, do you think that the public charging will sufficiently meet demand to meet EV adoption goals, or will widespread infrastructure in multifamily buildings or commercial buildings need to be built out? This is a great question. Some of my colleagues are working on exactly this. We don't really have a great idea, partially because it's really hard to understand just how many people actually can feasibly charge at home. We intuitively know, of course, that if you live in an apartment complex, there are just additional challenges, because maybe you don't own the parking or the shared space where you park your vehicle, if you're renting it, for instance, or even if you own a condo unit, maybe the parking is shared and it's managed by a collective authority. And so it's not clear yet exactly, but I would anticipate that it's going to depend heavily on the region. So in a region like New York City, I definitely think that there's going to need to be a lot of investment in those multifamily buildings and commercial buildings, provided we want to achieve a high level of adoption. If we're only seeing adoption in fleet vehicles and a small amount of personal vehicles, maybe we won't need quite as much. But if we really want to get widespread electric vehicle adoption, I definitely anticipate that the denser areas will need at least some, if not a sufficient amount of of availability to the multifamily instances. Someone asks, how do you see the possibility of big off-street operators invest on its private place, charging for the service, level 2, and create extra revenues as a value-added service? Yeah, that's a great point. Those are things a little harder for us to quantify in a project like this. But I think we're really interested in understanding and also helping that these technologies become more realistic for businesses to choose to install themselves. And so I'm not currently involved in any of this work right now, but of course, I think some of my colleagues are, and we're definitely very interested in trying to understand, how we can help make sure businesses and curb street managers even can start to look into generating revenue from those spaces that we add in charging infrastructure. It looks like I'm almost about time, unless one or two more questions. So I'll just wrap up here. Truck stops could make money by installing fast chargers on highways. The EV community could feel more confident on long range trips. Yeah, absolutely. And there's a lot of efforts going on to build out the infrastructure along our highways to make sure that we have enough distribution of chargers along the highways to support long distance trips. Yeah, absolutely. I know that Tesla does have all the superchargers around, especially at gas stations, but unfortunately, if you don't own a Tesla, you can't use them. So, all right, thanks.
Thank you very much, Chris, for being with us here today. I do want to remind everyone that we do have one final session. I put the link in the chat, so please feel free to click on that. It will take you to the final session. The final session will run starting at 4:15 until 5:15. So again, thank you very much, Chris, for being with us here today, and have a great day, everybody.
Thank you.